Okay. Hey everybody, how you doing? Sweet. Just had an exam. I know it changes things. Our relationship will never be the same. I'm sorry, or I'm not sorry, depending on how you did. Anyway, so everybody doing okay today? Good, good, good. We're going to start a whole new topic, really, a whole new sort of section of the course. Got a different outline, that's how you can tell, different background here. So I want to talk about the exam first for a little while. Just give you the basic statistics on it. And then what we're going to really do today is kind of ease into the next topic. When you're talking, we're going to talk now again, kind of going from social psychology into the study of individual differences, personality psychology, and some other things. But again, that's the central construct here in this next section of the course is this idea of individual differences. And so when you're talking about individual differences, you have to sort of understand measurement issues. And so we're going to talk a little bit about measurement sorts of issues, some things you might know, some things you may not know about or haven't thought too deeply about. We're going to talk about means and medians and variance and the bell curve and correlations and validity and reliability and a whole bunch of good stuff like that. So, the exam, scores are posted. Hopefully everybody's had a chance to see them. And again, the exam as a measurement tool worked very nicely, worked very much the way it typically does in this class. So there were 423 people total who took the exam. The mean, and again, we're going to talk more about what all these terms mean if you don't know or haven't thought about it in a long time. The average score was about 50 or 49. The median was about 50. And again, we're going to talk about what a median, if you don't remember. And the range is 63 to 21. So nobody got a perfect score, but people got, somebody got, just one wrong and all the way down to 21. And that's the distribution, what we call a histogram, and we're going to talk more about that, which shows a different score. So this is very much the way that means very similar to means in the past that we've seen. It's nice to get people who get almost every question right, which means that questions are answerable, and there's a range. So the thing that is always a little tricky to understand about this, right, is I don't curve this exam. Right, the whole course is curved, but this score goes in as a score. If you got a 49, you get a 49. It's not like everybody who gets from a 49 to a 53 gets a B or the same number, right? So the full richness of this curve is preserved, right? And then at the end, I stick a curve on it and say, the top 15% get an A, 25, 45, et cetera. So, but of course, everybody wants to know what they got on this exam. So I can take that same curve, that same idea, and say, okay, the people who the top 15 or so percent get an A, the next 25% get a B, the next 45% get a C, D, F, that kind of way. And if I did that, if I was going to give you a grade, right, for this exam, these are the kind of cutoffs that I would use. This is just using exactly the same course cutoff to understand this. So in other words, if you got a 57 or above, you're in the top 16% of the class, right? And so that would be the equivalent of an A. You should be happy. Oh, gee, I got an A. That's good. Maybe you want an A plus, and you want to move more, but you're in that range. The 56 to 52, there was 116 people, or about 27%. So the curve's a little fat at the top, right? So it's not 15 and 25, but 16 and 27. But again, that's the B range. 51 to 40 would be the C range. 39 to 35 is the D range. 34 or less is an F. And again, there's sort of fewer of those than the curve states, right? So this should give you a sense of how well you're doing in a class. And if you're not doing as well as you would like, now's your time. So this is, you've seen an exam. The other exams are going to be very much like this exam, right? So if you're not doing as well as you would like, you should really think about how you're going to address that, right? You're going to start going to discussion sections, and those discussion sections are out there. Are you going to go and look at your exam and do that? I would recommend that you look at your exam, right? If you have the interest in doing that, it's really, really helpful, right? And so you could go to any of the TAs during their office hours, and they will go over the exam with you, and I'll send you guys the stuff that you need to do that. Right, so what I say, if you want to come talk to me about and get advice about the exam, I'm really happy to do that, right? But what I want you to do first is go look at your exam. I want you to go over, before you come and talk to me about, well, what should I do to fix things, I want you to have looked at your exam. It's really helpful for me to say, oh, see, what kind of questions did you miss? You know, is it that you're not paying attention on the exam, you're not studying the right things, you're not, so by having you go over the exam and get a sense of why you got things right or why you got things wrong, right, then that's really helpful for me. But I want you to do that. So if you want to look at your exam, go to any of the TA's office hours, and they can go over the exam with you. Then you can come and talk to me, and I would be happy to go over here and talk about study strategies, etc. Any questions about any of that, about the exam stuff? You guys are so quiet. Good. Well, again, like I said, I think this exam is very typical of the way the other exams are going to look, right? I have a particular style, the way I ask questions, so those questions will be very similar. Hopefully, you got a sense of kind of the way I sample from things and the way questions are asked. So, another thing, go do your extra credit, right? Don't leave points on the table, right? So if you're not happy, or even if you are, now's the time to start doing all those things. Okay, great. No other questions about the exam? Awesome. We hold these truths to be self-evident, that all men and women are created equal. Right? We know that, right? So there's this tension that underlies all of sort of when we think about politics, when we think about how to evaluate people's lives, how to make people's lives better, right? We know that everybody has, the tension is always that everybody has equal value, but everybody's not the same, right? Just because people have equal value doesn't mean that they're all the same, right? We're different in all sorts of ways, right? If I look out across you, I see all the physical differences, right? And underlying those in terms of your abilities, your tendencies, your wants, your desires, your fears, all those ways people differ. And that's what we're really talking about today. If you're talking about human behavior, right? It's hard to just treat everybody as the same. You're missing something if you aren't sort of capturing the notion that humans differ in all sorts of interesting and important ways, and ways that it's important to understand them because it has to do with their well-being and their welfare and all the things that we care about. And so when we talk about social psychology, right, the whole notion that underlies that is that is this idea about situational influence. That when you walk into a situation, if I want to understand your behavior, I should understand the situation you're in, because your situation determines what you do, and it makes kind of everybody act in very similar ways, or most people act in very similar ways, right? So people don't. The reason we talk about social psychology sometimes is kind of counterintuitive to people, because they think about the world like a personality psychologist, like we're going to be talking about today, all the differences that people have, right? And social psychology, right, we want to make that point that people are more affected by situations than you would imagine, but don't miss the broader point, which is that people really are different, right? And if you look at social psychological studies, people don't all act the same. Not everybody shocks that old guy in the Milgram experiment, right? Somewhere, even in the classic situation, 63, 65% of the people are doing that. What are the other ones aren't? And in that movie, you see very clearly how at the beginning they start off with the people that say, no, I'm not doing that. Yeah, I know you want me to do that, but I'm not doing it. Right? So some people do it, some people don't. We put this up as an example of the power of the situation, how situations make people behave the same, but not everybody behaves the same. Similarly, any experiment, right? In the Ash line judgment studies, again, only 24% of the people never conform, right? So in any situation, we can kind of move people around. We know that by changing aspects of that Milgram situation, right, you can take people from almost a situation where almost everybody is going to obey to a situation where almost nobody is, right? So the situation can move things around, but not everybody does the same thing in any of those situations, right? Some of that's just what we call noise, right? So some of it is just random variation, various whatever's going on, the things that we can't understand, but some of those differences are real differences, stable individual differences. They're things that make people different from one another and the ways that people are different in a kind of stable way, right? And those are the kind of interesting things that we're going to try and get at. Noise, that you can never make anything do, everything do the same thing all the time. That's why we use statistics, right? Because there's always this sort of variation. We're going to talk about this concept of variation. Right? But we want to try to figure out, is there anything sort of real there? We know that situations have real impacts on behavior. So what impacts do individual differences have on behavior? So we're different in lots of different ways. Height, weight, all these sort of physical things that we can see, sense of humor, intelligence, personality, all kinds of ways. And of course, things like intelligence and personality, that's what we're going to be interested in. Not all the different other kind of individual differences people have, but these things and their differences in your abilities, things that psychologists have really been interested in over the years. Why did different people kind of behave different way, respond different way to situations? Why do people have different abilities? Like this concept of intelligence has been very controversial, and I'm going to talk about that next time. And again, differences, the term that psychologists use for differences is what they call variance, right? So variance is just how much people vary or differ on this dimension. Individual differences is how we vary from one another in relatively stable ways. And again, we're interested in the ways that people differ in consistent, stable ways in particular. So how do you start to understand differences? Well, we put people in some situation. We give them some kind of a test, right? So let's say this is just some random, reaction time test. Maybe it's how quickly you can recognize, a word. So we flash words up on the screen, and you have to say whether it's a word or not a word, right? And how you just do it as quickly as you can. Is that a word or not a word? Right? If I gave this test to all of you, you would end up distributing yourself and along this dimension. So this is your reaction time, sort of average reaction time in milliseconds, and how many people do that. Simple, we could just graph that out, right? Lay out, and this is what your scores might look like. And what you find when you do that kind of thing, right, is you end up with this. It tends to distribute itself in this very typical way. It's called the normal distribution or the bell curve. And this occurs with virtually anything that you graph, right? The world sort of is, if we look at people, we give people any kind of a test, a spelling test, jumping test, whatever it is, right? What you'll end up with is some people, if you put everybody onto a graph, right, there's going to be a place where at one end there's relatively few people who go really, really slow. There's a lot of people kind of in the middle, and there's a lot of people, I guess at this end is the slow end. who go slow. So some people do it really, really fast. Most of the people are in the middle. Some people go really, really slow, right? And as you move away from whatever this sort of central kind of tendency is, right, fewer and people get it. It's called the bell curve. It works on almost everything, right? So let me give you another example before we talk more about it. So get out your clickers. So just tell me how tall you are. So I'll give you a second to get these out. So if you're 5 foot or shorter, click A, 5'1" to 5'5", click B, 5'6" to 5'10", click C, 5'11" to 6'3", click D, and 6'4" taller, click E. Let me hit that, okay? So go ahead and respond. Tell me how tall you are. Okay, looks like everybody's in. Turn it off. So, yeah. Nobody 6'4"? I know the basketball team's not in here, huh? Wow. Well, so yeah, what you see is that same sort of pattern. You pick anything like this, right? There's relatively few people who are 5 foot or shorter, about 9%. The majority of people look like they're between 5'1" and 5'5". That's 51%, you know, a little fewer, but again, it kind of goes up there in the middle, you know, then in the next range, and then relatively fewer people were 5'11" to 6'3", and no people like that. That is the basic sort of normal distribution. Now, if we would have had you give your specific height, right, if I could have done that, then it would smooth out more nicely, right, but that's the way that distributions tend to go. There's a lot of people in the middle, there's relatively few people at the end. And so that basic notion of this, and you've heard of this idea of the bell curve, right? It's because it looks like a bell, and you're going to see that lots of times before, right? So that's what almost any distribution tends to look like, approximately, right? There tends to be some clumping of things around some central tendency, right? And the central tendency somehow is important. We want to know, well, how tall are people? Kinda. You know what I mean? Not you, how tall are you, but how tall are people? Or how well do people do this? Or how smart are some people? Or whatever it is you want to know. What do you mean by that? Well, we need to abstract out something that captures that fat part of the curve, right? That high part. What's kind of the typical tendency, the central tendency. And there's two sort of classic ways to think about that. There's what's called the median, right? So the median is a measure of central tendency, and it's a score that separates the top 50% and the bottom 50%. Right, so if you laid people out on some kind of a curve, you say, okay, I'm going to draw a line down here where there's 50% of the people here on the left and 50% of the people end up on the right. That's called the median. Splits people up into percentages, right? And you can split those up into 25%, whatever it is, but the median is that measure of central tendency. Somehow it captures some notion. Yeah, if you want to know how tall people are, right, okay, well, 50% of them are taller than this and 50% of them are shorter than that. So that kind of captures it. The other way that we describe the central tendency, right, is the mean or the average, right? And we all know this. It's just the total of all the scores divided by the number of the scores being summed, right? So if we go across all these scores and we average them, right, we figure out how many inches or centimeters all of you guys are. We divide it by how many you are, and we get some measure that says, yeah, the average height in here is like 5'7". What it sounds like, so it would be 5'8", right? Well, does that mean, what does that mean? Does that mean everybody's 5'8"? No. Does that mean that anybody's 5'8"? No, not necessarily. It just means that that's a way to capture that's a way about the average height, right? We know that, and they're funny things that you've heard about your whole life, right? You think about them, they're kind of, right? They're abstract, sort of interesting concepts. There's ways of describing sort of the typical tendency in people. Right? Now, usually a mean and a median are very close to one another, right? But they're different things, right? They're different measures that goes over, and so they can separate in a perfectly normal curve, and we'll talk a little bit again more about this, in a curve that has this sort of perfect form like this, where there's equal, where everything's kind of laid out nicely. The mean and the median are going to be exactly the same, right? And that exactly the average is also what splits 50 from 50. But curves aren't always like that. They become skewed in one way or another. They sort of approximate a normal curve, but don't look exactly like a normal curve. So for example, you can have a curve that's sort of skewed to the left like this, where a lot of, so it does have this thing where there's relatively few people at the bottom, it goes up and it comes down, but it's kind of skewed this way. An example might be, again, this is the housing prices in Newport Beach. So you wanted to graph every price of the houses in Newport Beach, right? So there's a lot of houses, maybe this is getting increasingly antiquated. But there's a lot of houses down here, there's almost nothing under $600,000. There's a whole bunch that are from $600,000 to $1 million or something like that. And then it goes all the way out. So there's some that are 10, 15, $20 million houses, right? But there's many more of them. The central tendency is sort of shifted this way, right? And that would work for both of them. And the more skewed it is, the more it pulls the median and the mean apart, right? So if you want to figure out 50% of the house, what's the line that says 50% of the houses are cheaper than that and 50% are more expensive? Well, it pulls it this way, right? Because there's so many at this end, right? To get 50 over here, for the area under this curve to be the same as the area under this curve, you got to move this over. But again, the mean's out here because there's some that are extended way out here. You got to, when you're calculating a mean, right? You got the house that's 15 million, 25 million over here, and it pulls that mean this way, right? Because these get weighted heavier because they're more expensive than those, right? So that's the way lots of curves are. They'll pull one way or the other, but the same, and that pulls the median and mean apart. And so that's why each of these sort of capture an important part of the information, right? A non-redundant part. Knowing what the median is, knowing how many people, what's the line that separates 50% above and 50% below, conveys something different than what's the average is, right? Particularly when curves get like this. Another example is again, this is the exam curve again, and this is kind of what I shoot for, right? I want it skewed the other way. I want more A's and B's than I want D's and F's, right? And they tend to do that, right? So it's a little bulkier. It's less, this is kind of drawing a perfect curve around it, but you can see it's a little bulkier on this end, just like the other one was, and that'll pull the mean and median apart a little bit in the same kind of way, right? Although our mean and median are very close together. So there's this sort of central tendency that's really important to understand about any distribution. If you want to know about any human characteristic, you want to kind of know what's the average. But you also want to know other stuff about it. And part of it has to do with this other, or the other sort of really central construct here, besides the mean, is the distribution or the variance or dispersion of the sample, right? So you can have, so these are all sort of graphs of distributions, right? Some where this pink one, where everybody's kind of clumped around the middle. Almost everybody's right near the average, and it drops off very quickly as you move away, right? A real narrow distribution versus the green one, which is a little fatter, and the blue one, which is even fatter and slubber. Well, everybody's kind of, it has that same tendency where there's a middle part, right, that where the most people are, but it also is sort of spread out. And that captures something really important about distributions. That's two things can have the same mean, but they can have very different variances, and that could make a lot of difference in how you evaluate that. So for example, and I'll go back to this in a second, right? Do you want to live in Washington, D.C. or in San Francisco? They both have an average temperature of 57.5 degrees. Does that mean they have the same weather? No, right? Well, they have very different kinds of distribution. So San Francisco ranges only from the average temperature in January to about 50 degrees up to, I don't know, the average temperature in August, September, maybe 63 degrees, right? A kind of flat distribution versus Washington, D.C., which has a much sharper distribution, or at least a little bit sharper, right? So it goes, it goes from 40, maybe 35-degree average in January up to an 80-degree average in the summer, right? So they have the same mean, but it's important to say, well, that doesn't mean they have the same weather, right? There's much more variance in the weather in Washington, D.C. It gets colder and it gets hotter, and San Francisco just kind of stays the same. And that's an important, if you wanted to live there, right, that would be an important thing to consider. And so what we need to do, another measure that psychologists use a lot, is they need to develop some measure of this distribution, not just where the central tendency is, but kind of how much dispersion, how much variance there is in a sample. And that is, the measure that we use for that is something that's called the standard deviation. Right? A standard deviation is a measure of variance. And essentially what it does is it imposes this sort of nice normal distribution on it in a sense. It says, okay, one standard deviation is the distance you have to go from the mean to capture 68% of the people. Right? So it's based on the actual distribution. Right? So one standard deviation means that there's 68% of the people within that, right? Now, if that's a skinny, right, if that's a skinny one, that 68 doesn't go very far, right? In order to get 68% of that pink one, you really only have to go a little, scale point or so. But to get 68% of that blue one, right, you have to have a lot more. Right? So that's but the basic idea of a standard deviation is it's a way to measure and describe how fat that curve is. And so if you say, if it's a skinny one, then the standard deviation tends to be relatively small, right? You don't have to go very far to get 68% of the people because they're all clumped in there. Right? If it's a fat one, you got to go farther, so the standard deviation is bigger, because to describe it as to get 68% of the people, you got to go right out farther. And again, two standard deviations is just the distance it covers 95% of the population. Three standard deviations covers 99%. Right? So it's just a measure that allows you to describe kind of how clumped up that is. So the example I had here, I forgot that I had up there, was this idea about, when they give confidence intervals. If you ever see polling data, they'll say, Obama's ahead of Romney by 5% with a 4% margin of error. And some have an 8% margin of error, or 2%. What does that mean? What do they mean, margin of error? Well, they mean how clumped up is everything, right? Is everything kind of dispersed a lot, so there's a lot of sort of error involved, you can't tell, or is everything kind of really tightly done, so there's very little around those. So it's that same kind of thing about dispersion, variance, this crucial concept that helps to describe individual differences. Does anybody have any questions about that? And again, how this sort of applies in this situation. So the standard deviation in the weather in Washington, D.C. is larger than the standard deviation of the weather in San Francisco, for example. Simple, right? There's all these statistical concepts are really kind of intuitive for the most part. So what we really want to do in psychology is explain that variance, right? We want to know what causes people to differ. If you're a medical doctor, you might want to be what causes people to differ in height or weight, what causes people to differ in health-related things. If you're a psychologist, you want to know kind of the same thing. So what makes people differ in intelligence? What makes people differ in personality? And the kind of, to just sort of set up the way, the way we're going to be thinking about this when we're trying to explain these things, a lot of what we do and what becomes interesting, particularly in the study of intelligence, but in lots of things as well, right, is to what extent that variance is due to the environment versus to genetics. These, kind of biological individual differences, right? So we want to know intelligence. Do we want to know, oh yeah, why do people differ in intelligence? Is it because of the situations that they're in, the way they're raised, their environment, or to what extent is it something genetic, right? That you're given some genetic endowment of intelligence, and that's really what determines whether you're up high, in the middle, or down low, right? Or, again, increasingly, what psychologists are realizing, right, is that it's a combination of the environment, that the interactions between the environment and genetics, between nurture and nature, right, are much more complicated than we used to think, right? And that almost everything is sort of a combination of those things, right? But this is the goal that we want to do. What I'm trying to sort of set up the groundwork for this, right, is you've got to try to figure out what the overall sort of strategy is to figure out the variance. So what determines how whether you end up high or low on something. So how do we figure all this out? Or what is, again, kind of laying the groundwork? How do we measure relationships? How do we tell whether individual variation is due to genetics, environment, both? Well, more generally, how do we tell whether two variables are related? Any two variables, right? That's the goal, right? We just want to see whether two things are related. Whether it's how much you studied for the exam and what score you got. It's something you might be interested in right now. Quality of your friendships and your happiness. Does how happy a person is depend on who their friends are? Or does it depend on something about themselves? Some people are just happy, not happy. Some, classic example, smoking and lung cancer. Does smoking cause lung cancer? Anything, right? So this is the basic scientific enterprise, is to try and figure out what's associated with what and ultimately what causes what, right? But this is just this general idea about we're interested in relationships. So what do we need to know about that? Well, this concept of correlation. Again, I think a lot of this hopefully will be, right, review for you guys, but I think it's important to go over it as we go forward, right? So a correlation, who can tell me what a correlation is? Describe it in their own words. Come on, go ahead. We got to talk way up. So a tendency for two variables to move together or apart, right? So what would make them move together?
If they're somewhat related.
Like, oops, I hit a button. So like we're related in what way?
Well, I don't want to say they cause each other, but because that's not what correlation is. But
Right, so
when one goes up, the other one goes up, or when one goes down, the other goes down.
Perfect.
That would show correlation.
Right, so that's what I wanted to get at. So when you're talking about correlation, right, it's just the association between those. It's just that the two go together somehow, just very much as you described it, that they move together in some way. They either go up together or one goes up as one goes down, whatever it is. It's not about the nature of the relationship. It's not about what causes the relationship. It's just that it's a measure that there is a relationship between two variables, right? So a correlation expresses the relationship between two variables, and it expresses both its direction and its strength. And again, we don't need to go into the mathematics of any of this, right? But it's just a simple idea of what a correlation coefficient does. So it varies from -1 to 1, and with 1 being a perfect strong relation, positive relationship, -1 being a perfect negative relationship, to 0 meaning that the two just aren't related at all, right? So, you know, in this left-hand top one, that's a perfect positive correlation, right, of 1. Where the idea is that you can use one variable to predict what the value of the other variable is. And if it's a perfect relationship, I know, for example, that if I move up 1 point on the x-axis, I can predict exactly where that dot should be on the y-axis, right? Because it's a perfect line like this. Most correlations aren't like that, right? Things aren't perfectly related. Height and weight. Are they related? Are taller people generally heavier? Yeah. Are they always heavier? No. Right? So they're related, but there's some noise in that relationship. It isn't perfect, and that's what most correlations are like. They're more like this one in the top right, for example. Again, that's a positive correlation. As one variable goes up, the value of the other one goes up, but there's noise in it. Well, sometimes there's skinny short people, heavier short people, skinny tall people, heavier tall people, right? It isn't quite perfect, but you generally know, right? And this is a correlation of 0.5, which is actually in psychology a very strong relationship. So you really, if you know how tall somebody is, right, you can get a pretty good guess of how heavy they are. Not perfect, right, but it tells you something. If I find out you're 6'4", I'm not going to guess that you weigh 95 pounds, right? Right, you're likely to weigh more than that, and that's what it is. It isn't perfect, but it's there. And again, a zero correlation is just nothing at all, right? One value doesn't tell you anything about the value of the other one, so they're not predictive. And the perfect negative relationship, right, is when it's just a way of expressing the direction of not even necessarily the relationship, but the measure of the relationship, right? So a positive correlation is just like two things are on a string. Like you pull one up. If I pull one up and it's attached to a string to something else, it's going to pull that one up. It may not pull it up perfectly. You know, the string may move a little bit, but we know that as one variable goes up, the other variable goes up, right? A negative correlation is just like a seesaw. As one goes up, the other one goes down. As one goes up, the other one goes down, right? They're just negatively related. And it doesn't always have to do with actually the construct again, but the measure of the construct. So here's an example. This is the correlation between spelling and reading scores, right? So if you give kids a test of how well they spell, give kids another test of how well they read, right? And you score them all on, I don't know, a 12-point scale, right? Oh yeah, there's this general relationship so that the better kids tend to do on the reading test, the better they tend to do on the spelling test. So the ones that did poorly on the spelling test tend to do poorly on the reading test, same like that, right? So there's a positive correlation. Well, let's say you do another measure though of how well things are going, and that in this case instead of measuring well, it doesn't say it. Instead of using the score, you measure spelling by how many mistakes they make. So it's a measure of how well you did on the spelling test, right? But in this case, higher scores mean worse performance. So because you've changed that, right, the nature of the relationship changes. Now, it's still the case that reading and spelling go together, right? But now when you measure it this other way, that the kids who do well on the reading test tend to make relatively few errors on the spelling test, right? And it's just because the measure of a performance on the spelling test has been switched around from kind of some score like how many you get right to a score like how many you get wrong, right? So you need to know when you're thinking about, when people talk about correlations and things, you need to keep straight kind of what the measure is, right? Because a positive and negative correlation, they're just a way of talking about the relationship, and things can switch from a positive to a negative if you measure something in a different way, depending on what higher scores mean, right? So it's important to kind of separate out the conceptual relationship, how you think they're related, and whether that's kind of and the measure of it, right, which sometimes can confuse people. But this is what we do, right? We try to figure out what goes with what correlates with intelligence, what correlates with other things. And again, as we, well, what do I got here? Did I miss something? I don't even know what my own slides are today. Let's see. Yeah. Okay, I don't work out. So, And again, this becomes crucial. What I'm trying to do is kind of lay the groundwork for some of the intelligence work. So we just saw a correlation between two different variables from the same person, but you can correlate anything, right? You can correlate variables, two variables that come from different people. So for example, in this example, this is the correlation between a mother's height in inches and her daughter's height in inches, right? Well, the variables come from two different people, but for reasons that we kind of understand, right? We know that they're going to, we can observe this positive relationship. The taller the mom is, the taller the daughter is. The shorter the mom is, the shorter the daughter is. Makes sense, right? We can do this. And these kinds of interperson correlations become very important for us when we're trying to understand certain kinds of individual differences. Like, for example, so this is a measure of two twins. And the height of two twins, not the height of a mother and a daughter, but the height of two twins. In this case, they're called DZ or dizygotic twins. Who knows what that means? What does it mean?
I got fertilized, split in two, so they're basically clones of each other.
They're what?
They're clones.
No, when they're dizygotic.
Oh no, that's the other one?
Uh-huh.
Two got fertilized.
Right, two eggs. When you have dizygotic twins, right, they're for what we call fraternal twins, non-identical twins. Right? So they can look a lot alike. Kids look a lot alike, but they aren't identical. They aren't exactly the same. Right? They're essentially dizygotic. This becomes, again, important, and we'll go over it again, but dizygotic twins are related the same way any other siblings are related. They have the same genetic relation. They're no more related to, even though they were in the womb together, right? They're no more genetically similar than you are to any of your other siblings, right? If you look at the height of two dizygotic twins, they tend to be positively correlated, right? If you get one twin that's tall, the other one tends to be tall. Same thing with your siblings. It's not perfect. I have a 6'2" brother, right? So somehow I ended up on the short end of the stick on that one, right? But generally speaking, tall families, they're tall, and shorter families are shorter, right? And two dizygotic twins are related, but not that related. Now, then the alternate, right, is got the little thing over there, but the monozygotic twins. And monozygotic twins are identical twins. They're genetically identical, right? Literally at the genetic level, the same individual, right? And so when you look at the correlation between the height of two monozygotic twins, two identical twins, notice what happens. Right? So the first thing to notice is that the mean doesn't change at all. Right? Nothing changes about the central tendency here. The mean height of these two samples is virtually identical. But the distributions aren't the same at all, right? And the correlation is the same at all, right? You see that there's a much tighter correlation here, much closer to 1, right? Because, well, identical twins, a lot of height is determined genetically, right? How tall you are it certainly is influenced by the environment, and there's a tendency humans are getting taller, better nutrition, all those sorts of things, allow people to grow better, but a large part of it is genetic. And so knowing how tall one twin is tells you very closely how tall the other twin is. When you're identical twins, you're very close to the same height. And that suggests, because those distributions are so tight, it suggests at least that there's some kind of genetic component to height, right? Because this difference between how dizygotic twins, the distribution you see there, and the distribution you see with monozygotic twins. Right? Again, doesn't change the mean, changes the distribution. That becomes important. It changes the correlation. That really becomes an important notion, right? So genetic differences are much better at explaining distributions and correlations than they are at differences in means. All of this, though, right, so that everybody get the basic concept of how correlations work and how that kind of thing can be informative psychologically and causally to what's going on. Right, informative to a certain extent, but again, it's important to recognize, right, that correlation, just to reiterate this point again that you made nicely, right? The correlation doesn't equal causation, right? Just because two things are related doesn't mean one causes the other. But sometimes that's the kind of data we have, right? We want to, it's circumstantial, it's suggestive, but again, it's not the same. Well, I think, how many people have heard this lots of times? Correlation doesn't equal causation, right? You get what that means, right? So if two things are related, you know, again, the classic example is smoking and cancer. Smoking is linked to mortality. You know, there's no question that there's a really clear correlation between the more you smoke, the more you experience a whole bunch of different illnesses, right? But that doesn't mean they're necessarily correlated, right? You know, and sometimes there are these funny correlations that you see in the world that don't work. So again, length of life is negatively correlated with the number of ashtrays you own. Right? The more ashtrays you own, the shorter you live. It's probably true, right? Does that mean that having ashtrays causes you to die? What does it mean? How do you explain that?
The third variable is you smoking causing you to die.
So there's a third variable, right? The you smoking, right? So it's obvious. So of course it doesn't, the ashtrays don't cause anything, but they're related to this other thing. The fact that you smoke causes you both to have more ashtrays and to die sooner, right? So that you would see a correlation between the number of ashtrays and how long they live, but that's not the causal thing. And right, and the same thing can be applied, logically at least, to any correlation between smoking and things like lung cancer. Well, maybe they're not, sure they're correlated, but maybe they're caused by some third variable. And in fact, a very famous psychologist named Hans Eysenck for a long time proposed that that was exactly the case, that the correlation between smoking and cancer was just a spurious correlation. It wasn't that smoking causes cancers, that both were related to this sort of neuroticism variable, that there was a neurotic personality that made people smoke and also made them prone to cancer. And so it really wasn't the smoking that was causing the cancer, it was some third variable. And with correlations, you can never know that for sure, right? You can never rule out those third variables. Right now in social psychology, we deal with this problem a lot by running experiments. And experiments are the way that you kind of get around this problem, by manipulating the variables, by controlling everything else. So if I could randomly assign you to smoke for the next 30 years and randomly assign you guys over here to not smoke for the next 30 years, and then try to, you know, impose a certain amount of control on what you did, then I could tell at the end of that whether smoking causes cancer or not. But in any correlational data, which is a lot of what you get in individual difference sort of studies, right, is you get a lot of just correlational data, this is related to this, and then you've got to try and, you have to be cautious and understand that it doesn't always imply causation. Sometimes it does, right? Doesn't always, and you have to be clever about trying to figure out other ways to identify the causes, which again is always what psychologists want to do. We want to figure out the causes of things. We just don't want to figure out relationships, we want to figure out causes, right? So that's a little bit about means, standard deviations, correlations. Any questions about any of this stuff? I want to talk about two other concepts just to kind of lay the groundwork for this. Right? So the next concept we want to talk about is validity. When you're talking about measurement issues, again, is this a crucial issue is whether the measure is valid or not, right? And we use the same term, right, in English all the time, a valid driver's license, a valid excuse, right? So valid just means, very simply, that it measures what it purports to measure, or it's sort of grounded in truth, that a measure is a valid measure of, it actually reflects the underlying construct that it's trying to measure. So what's a valid intelligence test look like? That it actually measures intelligence, not something else. Or a valid scale, or a valid, you know, whatever it is, right? It's that it measures what it purports to measure. Right? So I could do studies and say, well, I'm going to measure intelligence by whether or not you like me. right? The more you like me, the smarter you are. Right now we get a nice distribution, I assume, heavily skewed toward the positive end, right? And, you know, we could do all that, but and anything we would do would be, well, it's kind of silly because whether you like me or not is not a measure of your intelligence. It's not a valid measure. How would we know that? Well, there's various ways of trying to look to see, you know, what things, how do you know whether something's a valid measure? And there's a whole science, right, of psychometrics where they try to, you know, sort out how do you figure out whether something's actually a measure of what it purports to measure. Because psychologists very often are measuring things that are really kind of weird and complicated to figure out. Intelligence being a really good example. Like, what is intelligence? And we're going to spend a fair amount of time next time talking about that, right? It's not obvious what that is. You got to know what that is before you can measure it, and you got to know how to measure it, you know, before you can ever say anything about it. So there's this sort of complicated process, right? So how would you figure out whether something's valid? Well, one way is if it's what's called face valid, if it looks like a measure of what it purports to measure, right? So when I say, for example, that intelligence is measured by how much you like me, does that sound like that's a good measure of intelligence? No, doesn't have much face validity. A lot of, you know, here's a few items from a very famous scale in psychology. In most ways, my life is close to ideal. The conditions of my life are excellent. Do you agree or disagree? I am satisfied with my life. Agree, disagree? What do you think this measures? What's this a scale of? Anybody? Happiness. Quality of life. It's called the satisfaction with life scale, right? They said they want to know how satisfied are you with your life, and they ask you, hey, how satisfied are you with your life, right? That's the way they, how else would you ask that question? Sometimes that's the way we ask questions, right? And you could make up a fancier way, but maybe that way's a pretty good way. So sometimes that's one measure of validity. It just is what's called face validity. Does it measure what it sounds like it measures, right? But that isn't always the case, right? There's other ways of measuring things. We talked in prejudice, when we were talking about prejudice, we talked about measuring, you know, that with how quickly you responded to, you know, whether a face was black or positive or white or positive or negative, right? That isn't the most obvious way, but that's a, you know, and then you get into these problems. Well, then if it isn't really face valid, how else would you sort that out? And there's other kinds of validity, right, or other ways to sort of provide proof of validity. So besides face validity, there's something called convergent validity. So convergent validity, if you want to measure, see how well your life satisfaction scale, is that a valid measure of life satisfaction? Well, it has face validity. Well, but convergent validity is that if it's a valid measure of life satisfaction, it should correlate with other things. It should converge with other things that are also seemingly measures of how happy or satisfied you are with your life, right? So people who are, for example, who score high in that life satisfaction scale should also, if you ask them randomly, you know, how good a mood are you in, they should be saying, oh yeah, I'm in a more positive mood than somebody who scores less on that. And if both of those, if people who score high on life satisfaction and score high on positive mood, right, if those go together, you get more confidence that life satisfaction scale is measuring something like happiness or you know, how satisfied you are, how happy you are with your life, right? So sometimes you want things to go together, to converge. You also want things to, there's also a thing called discriminant validity. Right? So if something measures what it purports to measure, sometimes it shouldn't be correlated with other things. It should discriminate between those other things. So in lots of scales, what you get is what's called a social desirability problem. Right? That people just want to say, oh yeah, my life is good. Or how smart are you? Oh, I'm really smart. How good a driver are you? Oh, I'm a really good driver. Right? And so let's say you had a measure of social desirability, another scale that measured how much people tend to give answers that are overly positive. Well, then you would want your scale of life satisfaction to differ from those, right? You wouldn't want, if the more satisfied with your life you were with your life, the more socially desirable you tended to respond, right? If those converged, you'd start to think, well, that measure isn't really measuring how satisfied I am with my life. It's measuring whether I'm likely to give positive responses to things, right? So you want those to predict different things, to discriminate. right? So if something measures what it's supposed to measure, it should go with the things it's supposed to go with. It should not go with the things it's not supposed to go with. That's the other way to say it, right? Simple as you can get. And it should have predictive validity, right? So, and this is kind of related to the other, it should predict important things. So if that life satisfaction scale is really predicting satisfaction with life, well, that it should predict whether you act in certain ways, whether you're happy with your life. It maybe predict your success in life, or predict, whether, if we think happiness is related to physical illness or something, it should predict those things. So predictive validity is a lot like convergent validity, that if one thing goes up, the other one should go along with it, but it's kind of whether it's just another scale, whether you're just kind of confirming the scale, whether it's predicting something that's kind of more substantial, really. It's almost a semantic difference in some ways. Right, but that's just logic, right? If you want to, and we have to worry about this a lot, particularly with an intelligence test. Does it really measure intelligence, or does it measure something else? Right? How valid is it? Does it go with things it's not supposed to go with? Right? Does it correlate maybe with race or socioeconomic status? And then you wonder, okay, well, what's going on there? So the smarter you score, the more the poorer, or the richer you are. Well, is that because rich people really are smarter, or is that because the test is measuring kind of how rich you are, not how smart you are, in a sense? So all these issues of interpretation become really relevant, and they all come down to these real basic issues, right, of validity. Any questions about validity? Okay, clicker one. Another clicker question. Suppose you weigh yourself twice, 1 month apart. If your scale measures your weight as 10 pounds heavier the second time than the first time, you should A, get a new scale because this one's obviously broken, or get to the gym and lose some weight. Come on. You've probably gained weight. Which of those two things you think is true? So if you measure yourself, you weigh yourself twice across 1 month apart. You're 10 pounds heavier the second time. Does that mean you should get a new scale, or does that mean you should go to the gym? Okay. Go to the gym. Yeah, right? Makes sense. It's possible. And this is actually a funny way, or kind of funny, maybe funny, way of talking about reliability. That's besides validity, the other really central sort of concept that we need to understand in testing is reliability. And reliability is, there's kind of two ways. How reliable is that test? If you did it again, would it do the same thing? Is it really, again, it's related. It's not whether it measures what it's supposed to measure, but is it sort of a reliable scale? And if they're unreliable, they're usually picking up something else, right? It's sort of an indication that they're not valid, right? But reliability is again, this idea, and there's kind of two ways that we use it in psychology. Most often, I guess, you measure it once, you measure it twice, you should get the same result. So test, retest, reliability. So if I give you an intelligence test once, give it to you a month later, you should score the same way, right? We're going to come back to this, why that's different from weight, right? But if this test gives, every time you take the test, you get the same score, right? That means it's a reliable test. It reliably reflects your qualities on that. Another sense in which we use reliability is that, if a test is a good test, you should be able to kind of split it into parts. So if you got a 20-item test of depression, or a 20-item measure of life satisfaction, the idea is that if it's a good, reliable scale, you should be able to kind of cut those items and take half of the items, all the odd ones, and take all the even ones. And if you get a mean of those two, they should correlate really highly. Right? That's called split half reliability. Right? The idea is that scale kind of measures the same thing, and if you take any of the items, that they'll tend to correlate with one another. If they don't do that, then the test, you get the sense that some of those items must be bad, that you should just be able to randomly hack a test up into a couple of pieces, right? And the two parts I should be able to take 25, or not 25, whatever half of 64 is, 31 of your questions on your exam, and take the other 31, and your score should correlate pretty highly on those. If it was kind of a good exam, right? It was, kind of captured reliably in a valid way, again, captured your performance on this, right? It's important, though, and the reason I brought up the thing about the scale, right, is it is important to recognize that if that's, particularly with retest reliability, we're really talking about if you're measuring something stable about people, it should give you the same result every time, right? So intelligence is something that we don't think is going to differ much in people. That's the way, it really depends on how you conceive of it. But if you're conceiving of intelligence as a thing that you have, right, how smart you are, and that's, if you can really characterize people as smart people, less smart people, more smart people, right, that every time I give you a test of intelligence, it should show the same thing. If it differs a lot, well, then that, if sometimes you turn up smart, sometimes not so smart, then you don't know, right? If it goes up over time, then maybe you could say, oh, well, what seems to be measuring is kind of what you're learning, if it changes, but that's really different from how your basic intelligence level is. And it's important to understand what you're getting at. Now, something like a scale, the reason that's such a ridiculous example with the scale is if the scale changes by 10 pounds, well, your weight is something that varies. It can vary a lot over a month, right? So that you wouldn't say that's a broken scale just because it gives you it says you're 10 pounds heavier today than it did a month ago, right? It might be a problem with your scale, right? It's possible. But it's just as possible because we know that weight changes a lot, right? That you can have that kind of a difference. Right, so if you're thinking of intelligence as this thing that, for example, that doesn't change, then it should give the same response every time. It shouldn't matter the conditions of the test. It shouldn't matter, right, whether you're a year older or anything else. And that's what this idea of reliability is important to kind of understand, whether or not a test is reliable and how that relates to how you're conceiving of the underlying process and everything else. Right? Any questions about that? So this is all background, right? And just make sure we're all squared away to talk about it. And we're going to turn next time to this topic of intelligence, right? It's this crucial way that people differ, right? We've made it crucial, right? We really think this is an important thing, but it also, obviously is one of those things we think a lot about people. How smart are you? How able are you to think and perform well? What the heck is that? In order to figure out what intelligence is and what it's, first we have to figure out what it is. So what are we talking about intelligence? What do we mean? Right? And then what relates to it? Well, you can't figure out what relates to it until you figure out what causes it, until you figure out you're sure about what it means. You got to figure out how to measure it. How much do people vary on this? If they vary, what causes it, to what extent. All these things are also really, really relevant to things like group differences. And the two things that have become the really controversial aspects of intelligence research, right, are things like group differences. If there are group differences across race, ethnicity, gender, to what extent is that real intelligence differences or something else, right? And then the other issue is about change. So intelligence is one of those things that's always been wrapped up in change, in trying to figure out how do we make people smarter, right? The whole education process is founded on that. We look out across the world and we want to know, how do we educate people? How do we make them smarter so they'll behave in smarter ways, do smarter things? Hopefully the idea is that make the world better, right? And what do we need to know? If we want to change something, can we change intelligence? Is it changeable? It's all, these things are all wrapped up in what causes it, how you think about it, what it is, how you measure it, right? And that's what we're going to pick up on next time and talk about this sort of historically controversial issue of intelligence. Any questions? Good, we're going to end early. We're out of here. Go, if you want to see your exam, go to your TAs and make an appointment to see them or just go on into their office hours. We'll see you guys on Thursday.